Now we're going to learn how to solve quadratic equations within an exponential or a log equation. On our first example, notice that the power on the first e is 2x and the power on the second e is x. That appears a little bit quadratic, right? We have a power of 2 and then a power of 1 with our variables. So I'm going to subtract 4 from both sides to get this in a quadratic form that we can factor using t-chart. What multiplies to -4 and adds to -3. The reason this works is because e to the x times e to the x means we add the powers. X plus x gives us 2x. So back to my question, multiplying to -4, adding to -3, we get a +1 and a -4. Setting each binomial equal to 0 to solve. It said first give exact answers. So we have e to the x equals -1. Taking the natural log of both sides to cancel my e. Second one, adding 4 to both sides and taking the natural log to cancel my e. So my exact answers would be the natural log of -1 and the natural log of 4. Hopefully you recognize we can't take the natural log of -1. That is outside the domain of a log, so it's an extraneous solution. So our one exact answer is natural log of 4, and for a decimal approximation, we have 1.386. Our second example, very similar to the first, factoring this using t-chart, what multiplies to a +6 and adds to a -5, we would have -2 and -3. Setting each binomial equal to 0 and solving. We get e to the x equals 2, taking the natural log of both sides. Or we get e to the x equals 3 and take the natural log of both sides. This time we have the natural log of two positive numbers, so we do have two answers on this one. Our exact answers are the natural log of 2 and the natural log of 3. For the natural log of 2, we have about 0.693. And for the natural log of 3, we have about 1.099. Next, we have quadratic log equations, and we will solve these entirely without a calculator. We'll start by condensing to a single log, which means we will multiply the 5x and the x minus 1. Using distributive property there, I've got 5x squared minus 5x. To cancel the log, I'll use curly law. We have 10 to the second power, or 100, equals that 5x squared minus 5x. Because all of my numbers are divisible by 5, I'm going to divide everything by 5, and I'm going to move my x squared and x term to the left where we're used to seeing it. Dividing 5x squared by 5, dividing 5x by 5 equals 100 divided by 5. Subtracting that 20 from both sides, so I've got my quadratic form. I can use t-chart, what multiplies to a -20 and adds to a -1. We get a +4 and a -5. Setting each binomial equal to 0 and solving, I have x equals -4 or x equals 5. This started as a log, so I must check my answers. It looks to me like -4 will be extraneous. And it is. Substituting that into the 5x, when I multiply that positive by a negative, I get a log of a negative, which is outside the domain. So this is an extraneous solution. Double checking my 5, multiplying it by a positive looks good, and subtracting 1, I still have a positive value. So my only solution is x equals 5. Part B, I'm going to start on the right-hand side and condense to a single log. This one's subtraction, so I condense to division. Now I have natural log equals natural log, so I can drop the logs and just have x plus 5 equals x minus 1 over x plus 1. In order to solve, I do not want any variables in the denominator, so I'm going to multiply both sides by x plus 1 to cancel my denominator. On the left-hand side, I'll use distributive property, plus 5x plus x plus 5. Combining my like terms, and I'm going to subtract the x from both sides. I'm looking at that one. So that one cancels, leaving me with 5x. And then I'm also going to add my 1 to both sides so I can set this equal to 0. Factoring what multiplies to a positive 6 and adds to a positive 5, I get a plus 2 and a plus 3. Setting each of these equal to 0 and solving, I get x equals negative 2 and x equals negative 3. Checking my solutions, they are both negative, so it doesn't look good that my initial equation has a solution at all. On the left-hand side, if I add 5 to both of my answers, they become positive. So it looks good so far. But on the right-hand side, when I subtract 1, negative 2 minus 1 is negative 3. Negative 3 minus 1 is negative 4. They are both outside the domain of a log, so we have no solution to this equation. And you have one U-Try question today.